Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. I'm excited to delve into the synergy between RAG and fine-tuning and explore the innovative techniques developed to enhance LLMs for specialized domains and factual accuracy. Can you shed light on the key principles and use cases of these approaches?
Sure. I'd be happy to shed light on the key principles and use cases of RAG, Retrieval-Augmented Generation, and fine-tuning. Key principles. RAG. RAG enhances LMS with external knowledge during inference, allowing them to access and incorporate relevant information from external sources into their responses. Fine-tuning. Fine-tuning specializes a generic LLM by fine-tuning its parameters on data from a specific domain of interest, enabling it to acquire knowledge and linguistic patterns tailored to that domain. Synergy and use cases. Combining RAG and fine-tuning techniques creates LLMs that are both knowledgeable and domain-specialized. Here are some key use cases. Domain-specific knowledge enhancement. Fine-tuning an LLM on domain-specific data imparts specialized knowledge and expertise, allowing it to generate more accurate and relevant outputs within that domain. External knowledge integration. RAG enables LLMs to access and incorporate external knowledge during inference, enhancing their factual accuracy and ability to handle complex questions. Improved downstream task performance. The combination of fine-tuning and RAG leads to improved performance on downstream tasks related to the fine-tuned domain. In summary, the synergy between RAG and fine-tuning allows the creation of LMS that possess both domain-specific expertise and the ability to leverage external knowledge, resulting in more knowledgeable, accurate, and versatile language models.
Thank you for providing the key principles and use cases of RAG and fine-tuning. To further clarify, can you elaborate on how these techniques are implemented in practice? What specific methods and algorithms are employed to combine RAG and fine-tuning? And how do they contribute to enhancing LLM performance?
The Retrieval-Augmented Generation, RAG, approach synergistically integrates with fine-tuning to enhance the performance of language large models, LLMs. Here is how this integration works. Retrieval module. The RAG framework incorporates an information retrieval system that allows the LM to access external knowledge sources during inference. This enables the LM to retrieve relevant documents, case laws, studies, or domain-specific knowledge bases. Planning module. The planning module analyzes the input question and generates a high-level plan represented as a sequence of relations. This plan provides guidance to the retrieval module in locating specific paths in the knowledge graph that may contain the answer. Reasoning module. The retrieved paths from the knowledge graph are provided as context to the LLM. The LM then leverages its reasoning capabilities to combine the information from these paths and generate an answer. Fine-tuning. The key aspect is that the LM is fine-tuned on question-answering data from knowledge graph datasets. During fine-tuning, the LM learns to generate valid relation paths grounded in the knowledge graph, planning optimization. Reason based on the retrieved paths from the graph, retrieval reasoning optimization. This fine-tuning process ensures that the LLM can perform faithful and interpretable reasoning by leveraging the structured knowledge encoded in the graph. The generated answers are grounded in the explicit paths retrieved from the knowledge graph, enhancing interpretability and trustworthiness. By combining the strengths of retrieval and fine-tuning, the RAG-U fine-tuning approach enables LLMs to ground their reasoning and generation in external knowledge sources, mitigating the issue of hallucinations and improving the accuracy and reliability of the generated responses.
Thank you for providing a detailed explanation of the implementation of RAG and fine-tuning for enhancing LLM performance. To further explore the practical applications of these techniques, can you provide specific examples of use cases where the combination of RAG and fine-tuning has led to significant improvements in LLM capabilities?
Here are some specific use cases where the synergy between RAG and fine-tuning has significantly enhanced the capabilities of LMS. Question answering by combining RAG's access to external knowledge with the domain specialization of fine-tuning. LMS can provide more accurate and comprehensive answers to questions, particularly in domains where information is constantly changing or incomplete in the fine-tuning dataset. RAG can retrieve up-to-date information from external sources, while fine-tuning ensures that the LM can effectively incorporate and synthesize this knowledge. Knowledge-intensive writing tasks. Fine-tuning LMs on domain. Specific data improves their ability to generate text that is both coherent and relevant to the domain. By incorporating RAG, LMS can access external knowledge sources to enhance their grounding in factual information. This combination is particularly valuable for tasks such as report writing, summarizing research findings, or creating technical documentation. Domain-specific summarization. Fine-tuning LMs on domain-specific data enables them to capture the linguistic patterns and nuances of that domain. By integrating RAG, LMS can access additional domain-specific knowledge from external sources. This allows them to generate more informative and comprehensive summaries, even for complex or technical topics. Conversational AI. By leveraging RAG's ability to retrieve relevant information, LMS can engage in more knowledgeable and informative conversations. Fine-tuning on domain. Specific data ensures that the LM can provide tailored responses relevant to the user's query. This combination is essential for building conversational AI systems that can assist users in a wide range of domains, such as customer support, healthcare, or financial advisory.
Thank you for providing these insightful examples of how RAG and fine-tuning have enhanced LM capabilities in practical applications. To further delve into the technical aspects of these techniques, can you elaborate on the evaluation metrics used to assess the performance of RAG fine-tuning methods? How do these metrics measure the effectiveness of the combined approach?
RAG and fine-tuning methods are evaluated using a variety of metrics, including retrieval-based metrics. Recall at K measures the percentage of questions for which the correct answer is retrieved within the top K results. Mean reciprocal rank, MIR, calculates the average inverse rank of the correct answer in the retrieved list. Generation-based metrics. BLOW compares the generated answer to a set of reference answers, measuring the overlap in n-grams. ROUGE, similar to BLUE, but also considers word order and recall. METEOR combines BLUE and ROUGE scores, along with a penalty for synonym usage. Entity F1 evaluates the accuracy of named entity recognition and linking in the generated answer. Chain of thought accuracy assesses the model's ability to generate a valid chain of thought, rationalizing its answer. Additional metrics. Inference time measures the time taken by the model to process a query and generate an answer. Memory usage evaluates the amount of memory consumed by the model during inference. Explainability assesses the model's ability to provide clear and understandable explanations for its answers.
Thank you for providing insights into the evaluation metrics used for RAG fine-tuning methods. To gain a deeper understanding of how these techniques compare to other approaches, can you elaborate on the advantages and limitations of RAG fine-tuning compared to alternative methods for enhancing LLM performance?
RAG, retrieve and generate, and fine-tuning are two powerful techniques that can be used to improve the performance of language models. LMS. RAG involves retrieving relevant information from a knowledge base, while fine-tuning involves training the LM on a specific dataset. By combining these two techniques, we can create LMNs that are not only knowledgeable but also able to reason and generate text that is relevant to a specific domain. One of the main benefits of using RAG fine-tuning is that it allows LMs to access external knowledge. This can be very useful for tasks that require the LM to have a deep understanding of a particular subject matter. For Example: a RAG fine-tuned LM could be used to answer questions about a specific medical condition, or to generate code that is tailored to a specific programming language. Another benefit of using RAG fine-tuning is that it can help to improve the LLM's reasoning specialization. By retrieving relevant information from a knowledge base, the LM can learn to make better inferences and generate text that is more coherent and consistent. This can be very useful for tasks that require the LM to understand the relationships between different pieces of information. However, there are also some limitations to using RAG fine-tuning. One limitation is that it can be computationally expensive. This is because the LM needs to retrieve and process information from a knowledge base, which can take a significant amount of time. Another limitation is that the LM may not always be able to find relevant information in the knowledge base. This can lead to the LM generating text that is inaccurate or incomplete. Overall, RAG fine-tuning is a powerful technique that can be used to improve the performance of LMS. However, it is important to be aware of the limitations of this technique before using it in a production environment.
Thank you for providing a comprehensive overview of the advantages and limitations of RAG fine-tuning. To further explore the scope of these techniques, can you discuss potential future research directions and applications of RAG fine-tuning in various domains?
The synergy of RAG and fine-tuning holds promise for various other knowledge-intensive domains, including finance, education, customer support, and decision support systems. As research in this area progresses, we can expect to see more sophisticated techniques that seamlessly integrate external knowledge into language models, enabling more knowledgeable, grounded, and trustworthy AI systems. One promising direction for further research is to explore the use of RAG fine-tuning for knowledge-intensive tasks that require reasoning and grounding in factual information. For example, in the finance domain, RAG fine-tuning could be used to develop AI systems that can analyze financial data, generate reports, and make recommendations based on a deep understanding of financial concepts and market trends. In the education domain, RAG fine-tuning could be used to develop AI systems that can provide personalized learning experiences, answer student questions, and generate educational materials tailored to individual student needs. In the customer support domain, RAG fine-tuning could be used to develop AI systems that can handle complex customer inquiries, provide accurate and relevant information, and resolve issues efficiently. In the decision support domain, RAG fine-tuning could be used to develop AI systems that can assist decision-makers by providing comprehensive analysis, identifying potential risks and opportunities, and generating recommendations based on a deep understanding of the relevant knowledge and data.
Thank you for sharing these exciting future research directions and potential applications of RAG fine-tuning. To further explore the technical aspects, can you delve into the challenges and opportunities associated with implementing and deploying RAG fine-tuning models in real-world applications?
Integrating RAG and fine-tuning in real-world applications inevitably comes with challenges and opportunities. One of the key challenges lies in the need to carefully curate and process the knowledge sources used for retrieval. The quality and relevance of the retrieved information significantly impact the overall performance of the RAG model. Ensuring that the knowledge sources are comprehensive, up-to-date, and aligned with the target domain is crucial. In addition, the retrieval process itself must be efficient and scalable to handle large volumes of knowledge data effectively. Another challenge stems from the computational cost associated with fine-tuning large language models. Fine-tuning typically requires substantial computational resources and can be time-consuming, especially for large datasets and complex models. Optimizing the fine-tuning process to minimize the computational overhead while maintaining model performance is an important consideration. On the other hand, The synergy between RAG and fine-tuning presents several opportunities for practical applications. By leveraging the knowledge grounding capabilities of RAG and the domain adaptation abilities of fine-tuning, it becomes possible to develop language models that exhibit deep domain expertise and can handle complex reasoning tasks. This opens up a wide range of possibilities in domains such as question answering, fact-checking, decision support, and personalized recommendations. Furthermore, the integration of RAG and fine-tuning facilitates the creation of more knowledgeable and trustworthy AI systems. By grounding the language models in factual information and domain-specific knowledge, we can mitigate the risk of hallucination and bias, leading to more reliable and responsible AI applications.
Thank you for highlighting the challenges and opportunities associated with implementing and deploying RAG fine-tuning models. To further understand the practical implications, can you provide insights into how these models can be integrated into existing NLP pipelines, and what considerations should be taken when doing so?
Sure. I'd be pleased to share some insights on how to integrate RAG fine-tuned models into existing NLP pipelines and some considerations to keep in mind during the process. Integration process. 1. Identify the NLP task. Determine the specific NLP task for which you want to leverage the RAG fine-tuned model, e.g. question, answering summarization, text classification. 2. Select a suitable RAG fine-tuned model. Choose a pre-trained RAG fine-tuned model that is specifically designed for the task at hand. Consider factors such as the model's performance on relevant benchmarks and its alignment with the domain of your application. 3. Incorporate the model into the pipeline. Integrate the RAG fine-tuned model into your existing NLP pipeline by replacing the original language model or fine-tuning component with the RAG model. Ensure that the input and output formats of the RAG model are compatible with the rest of the pipeline. 4. Evaluate and refine. Once the RAG model is integrated, evaluate its performance on a held-out dataset to assess its effectiveness. Based on the evaluation results, fine-tune the model's hyperparameters or consider alternative RAG models to optimize performance. Considerations. 1. Computational resources. RAG models can be computationally expensive, especially during inference. Consider the availability of computational resources and optimize the model's efficiency if necessary. 2. Data requirements. RAG models require access to external knowledge sources, which should be of high quality and relevant to the task. Ensure that the knowledge source is accessible and compatible with the RAG model. 3. Interpretability. RAG models provide interpretable reasoning by grounding their outputs in retrieved paths from the knowledge source. However, the complexity of the reasoning process may vary depending on the task and the knowledge source. Consider the desired level of interpretability when selecting the RAG model and knowledge source. 4. Maintenance and updates. RAG models may require maintenance and updates as the knowledge source evolves or as new NLP techniques emerge. Plan for ongoing maintenance to ensure the model's continued effectiveness. By carefully considering these factors, you can successfully integrate RAG fine-tuned models into your NLP pipelines and leverage their benefits for improved performance and interpretability.
Thank you for providing valuable insights into the integration of RAG fine-tuned models into NLP pipelines and the considerations involved. To gain further practical understanding, can you share some real-world examples of how these models have been successfully applied in various domains, and the specific challenges that were addressed in each case?
What are real-world examples of successful applications of RAG fine-tuning models in various domains? And what specific problems have been solved using these models?
Thank you for providing valuable insights into the integration of RAG fine-tuned models into NLP pipelines and the considerations involved. To gain further practical understanding, Can you share some real-world examples of how these models have been successfully applied in various domains, and the specific challenges that were addressed in each case?
Currently, there are no real-world examples of successful applications of RAG-Jo fine-tuning models in various domains. However, research in this area is ongoing, and we can expect to see more sophisticated techniques that seamlessly integrate external knowledge into language models, enabling more knowledgeable, grounded, and trustworthy AI systems.